chapter 1.2b that I'm doing this video for. Starts on page 28, and we're looking at valid and invalid measurement. So what is a valid or what is an invalid way to measure the data that you're looking for? Okay, so that's the big idea here. My highlighter is about to go out. When is a variable valid? So it talks about, when you read page 28, it'll talk about getting into college and how do you measure that, and is it a valid way to measure college readiness just by test scores? So this little part of the chapter is going to go through how do you tell if something is valid and what kind of data would you use for it. Okay, so when is a variable valid? Right there, if it is relevant or appropriate as a representation of that property. What becomes really important here, I know we've talked about this before, is using rates instead of counts. Well, we've talked about using rates and counts, and here it's saying using rates instead of counts is a more valid measure. And if you read through example 1.13, measuring highway safely, and that starts at the bottom of page 29. Okay, and what it talks about is okay, 20 years ago, if I count the number of accidents that there were, there's going to be less accidents than there are today because there are more people, more drivers, more cars, more everything. So if you use a rate instead of that count, and please read through this example and get the exact numbers and stuff. It's right here at the bottom of page 29. Okay, so if they use the rate where they take the number of motor vehicle deaths over the number of miles driven, okay, then they can get numbers they can compare. So this would be today's rate, I believe, the 1.53, and 1.91 in 1991. So they have, in fact, dropped, the number of deaths have dropped even though we have more vehicles and more drivers. So if you look at the rate instead of the count, it's going to be a little bit more valid. If an idea is vague, the validity becomes a matter of opinion. And you can notice this if you ever argue with Dom, is that he will argue that what you're saying isn't correct because of the definition of what you're looking at. And Dom, I thought that was funny because you were the first person I thought of when I read about this idea in the book. If you look at example 1.14, achievement tests, it's talking about just what we were talking about, like is an ACT a valid way to measure your college readiness? But what it talks about is like you can debate that, because what does it mean to be college ready? But also in example 1.14, it talks about tests for like AP exams here, and that it says is a more valid way to measure because they can look at the syllabus, like what were you supposed to have learned, and then they can look at the test questions and say, do those test questions match what you learned? And that is a really simple way to tell if that's correct. Whereas college readiness, are you looking at are you ready to live in a dorm? Are you ready to do your homework? And if that's the case, then how do you test that? And we'll get into that a little bit farther along in this part of the chapter because it discusses it. Example 1.15, IQ tests. Okay, it says here when you read through it, this is again what we were talking about with vague ideas. You first have to understand what is your definition of intelligence. And currently, there are so many different ways to measure it. How are you going to have a test that covers everything like that? So right here that I highlighted, the disagreement over the validity of IQ tests is rooted in disagreement about the nature of intelligence. If we can't agree on exactly what intelligence is, we can't agree on how to measure it. So in order to have a valid measurement, you really have to have a good definition of what it is you're looking at. Like we were doing with those songs, you could debate whether or not those words that we chose to count, which maybe we should go back and make a rate of that based on how many words there were in the entire song. But is that a valid way to measure if the song is more selfish or non-selfish. So that was kind of a vague idea. I should have looked a little bit more into that. 1.16, the SAT again. This talks about how women do more poorly on the SAT exam, and is there a problem with the actual exam? And what they decided in the study that they did was it's not, because more women from poorer backgrounds apply to college. So men from the same background as those women wouldn't even apply for college. So it's not so much to do with the fact that they're women as with the fact that they grew up without the resources that other people have grown up with, which in itself is a huge problem. But right here highlighted, the mere fact of lower scores doesn't imply that the test is not valid. So that finishes the examples from this section, but I would really love for you to go back and read them and see, and again, this book is 15 years old. Do you feel like those still hold true today? Okay, I would like to know what you think about that. The last thing we're talking about is predictive validity, right here. A measurement of a property has predictive validity if it can be used to predict success on tasks that are related to the property measured. And it's talking about SAT again, right here below example 1.16. And what it's talking about in this one is that you can predict that more students graduate from college that have higher SAT scores. Regardless of why they are graduating from college, you can still predict that higher SAT scores will have them graduating for college. It predicts that they're more likely to graduate from college. And what it says right there is that in your predictive validity on page 31, it's the only kind of validity that data can assess directly. So unlike intelligence, where you're trying to predict exactly how smart somebody is using the IQ test, maybe you could use the IQ test to predict something like how much money you're going to make. Does a high IQ score predict that you're going to make money? And from everything I read, it's quite the opposite. People who work harder are going to make more money regardless of their IQ score. And ironically, higher IQ scores make people, from this book I just read, I'll get you guys the information, don't work as hard because they're used to things just coming to them without having to work as hard for it. So that finishes up part B of 1.2. There's only going to be one more, part C, where we talk about errors in measurement and the 3 or 4 different kinds of errors we're going to look at. For right now, to get credit for this lecture, what I'm going to need you to do is go to the link at the bottom, which is a quiz, and it's going to tell you your millennial score. How millennial are you? And I want you to post that score in the comment section, and that is going to give you your points for this section. I will see you guys soon.